Hello, everyone, and welcome to the Missouri River Basin Climate Outlook for May 1st, 2014. I am John Ives with the National Weather Service, and we have also on our distinguished panel today Dennis Toddy, who will be our presenter, Doug Cluck from NOAA's NCDC, Kevin Lau from the Missouri Basin River Forecast Center, and Kevin Stam with the U.S. Army Corps of Engineers. Our presenter today is Dr. Dennis Toddy from South Dakota State University. He is a state climatologist there. And without further ado, we'll have Dennis start in just a moment. Just one reminder, we will keep the phone line muted for everyone during the call to keep it nice and clear. And we will then entertain questions at the end of the presentation. So Dennis, we'll let you take it from there.
And Kevin, when you guys come on, you'll have to do a #6 to unmute yourself there. So good afternoon, everyone. Welcome. I think it's afternoon for everybody who's sitting in on this. So hopefully you're seeing sunshine where you are. Here in Brookings, we can see where the light of the sun is, but still haven't seen the sun in several days. So there are people getting a little concerned at this point, would like to see some sunshine at this point. This, again, is a special additional webinar to our regular monthly webinars to address specifically Missouri River issues, precipitation conditions, and the impact on flows in the Missouri River. I will be joined by Kevin Lau from the Missouri River Basin Forecast Center and Kevin Stam from the U.S. Army Corps of Engineers as we go along. Just recognizing, again, all of our partners within NOAA, state climatologists, regional climate centers, Bureau of Reclamation, and the U.S. Army Corps of Engineers. So moving along, we can get on to our next slide here. Just a reminder of who all of our folks are who are part of this. It is a great collaboration activity among federal and state partners to be able to provide the information, gather what information we have, and provide that to you. It's part of our regional work on climate services, trying to provide information for decision makers. Our next regular webinar will be May 15th, Thursday, May 15th at 1 p.m. As for another Missouri River webinar, we will tentatively list one 2 weeks after that on May 29th. We will, if there is great interest from the group, we will offer that. Also, pending if there are any issues, any further issues that arise, that would lead us to do that. But right now, we're listing that as a tentative webinar. That would probably be the last one, barring anything largely unforeseen. Just a reminder of our links to where to find the webinars and the follow-up for them. Okay, our agenda today, we'll review current conditions and some comparisons. Then we will get to the river status from the Corps of Engineers and from the Missouri River Basin Forecast Center, and then move on to our outlooks for the rest of the upcoming season. Again, just a reminder, looking back at what is partially driven part of our problem here, or part of our level of concern, is precipitation. This is over the High Plains region from Montana down here to Colorado and Kansas. This is total precipitation during the water year, which we consider from starting October 1, and the percent of normal precipitation over that time frame. The blizzard in the fall and heavy rainfalls has put us still over 150% of average to present in parts of Montana, Wyoming, and the Dakotas. But you also note some very dry areas now showing up in parts of Montana, central and northern Montana, and down into southeastern South Dakota and Nebraska, where fall precipitation was much less and winter precipitation was actually much less. So we have kind of a dichotomy here of winners and losers as we go along. You'll see that signal showing up in a couple things as we go. If we look more currently at recent changes since our last webinars, where we've talked about upper left-hand side is precipitation over the last 30 days, the month of April it lines up, and on the lower right-hand side, the percent of normal for that same time period. You see the purple areas indicating 150, 200% of average up in the Dakotas over to Minnesota, and a couple parts of Wyoming and South Dakota, but not widespread. And you see large areas of Montana Nebraska, Wyoming, and southeastern South Dakota, which are running less than half, or a few spots even less than 25% of average precipitation over the last 30 days. This is showing up quite readily in some fire issues down in these areas, a few fire issues out in Wyoming, which has led to a story I'll tell you in just a little bit, and some reduced runoff in some certain places. Looking at temperature, where we're sitting with temperature over the last 30 days also, while we have been running on the cool side overall, average temperatures in the mid-30s and from western Wyoming, the mountains of Wyoming, and up into northern North Dakota. The departures from average are running just below average, roughly from Montana into North Dakota and the northern part of South Dakota, and just south of there, near average to slightly above average. So overall, still running a little on the cool side, but not nearly as bad as we were throughout the larger part of the winter. So it kind of gives you an update on the current climate conditions from way in temperature and precipitation. Looking at the soil moisture perspective, this incorporates some of the near-term dryness and precipitation back to the fall, which is an interesting combination of part of the story here. These are, again, departures. This is from NLDAS, an ensemble of different soil moisture models. There's some variability in how the models are representing the area, but the ensemble basically indicating much of Montana, western Dakotas, and Wyoming, still some carryover moisture from the fall, but this is deeper in the soil moisture profile. The numbers here are in millimeters, so you divide by 25 to get inches. 1 to maybe as much as 4 inches above average out in these areas. And those areas that had been drier since the fall, Nebraska, parts of South Dakota, and spotty areas, running below average, that same 1, 2 to 4 inches below average in certain areas. What this is kind of an odd story in the whole situation. I heard from Wyoming last week, where they were fighting grass fires, and they had trucks out on some of the prairie areas, but the trucks were getting stuck because the surface had dried out sufficiently that their fires were capable of occurring, but underneath that crust on the surface, the soils were still quite moist underneath. So the trucks were breaking through that crust and then getting stuck in the mud. So an odd picture of fighting fires while getting trucks stuck in the mud. Moving on to the U.S. Drought Monitor, reflects kind of those overall situations that we saw there, where most of the Missouri Basin, upper Missouri Basin, is free of any kind of drought conditions. A little bit of D0 has been introduced over the last couple of weeks in eastern South Dakota, reflecting that recent dryness. Not so much in Montana at this point, and then the ongoing dryness further south in the plains that is leading to the lower part of the Missouri River Basin. We tend not to get much changes in this over winter because the overall amount of precipitation we get during the winter time is relatively small compared to the overall amount of precipitation we get throughout the year. But we are reaching that point into May and early June that are the peak precipitation times up in this region. So we're watching precipitation very carefully for the impact on drought monitor status. Also, a quick look at USGS stream gauges, average stream flow over the last 7 days. Same kind of scale here. Greens are near the middle of the distribution. Ones that are in the light blue up to darker blue and even to black, indicating increased stream flows. A combination of precipitation from the last storm and the beginning of the snowmelt. Within the last couple of weeks, we have started pushing that snowmelt along, which we'll talk about more here in just a second. So most of the Dakotas and Montana, Wyoming, running into near middle of the distribution to high-end stream flows in some of those areas. As we get further south in the basin into Iowa, Nebraska, reduced flows, so there will be some less addition of moisture from stream flows down in those areas. Oddly enough, being on the 1st of May, we still do have some frost deeper in the profile. This is largely confined to parts of North Dakota and South Dakota. What we're looking at here On the left, on the upper left-hand side, is the depth of that frost. Williston still reporting 57 inches depth, Aberdeen 40 inches. But to complete the picture here on the lower right-hand side, this is the level where it is frozen, where it is thawed. So at Williston, we're only frozen from 57 inches up to 25 inches. Above 25 inches, we're thawed. Aberdeen has a level from about 40 inches to 27 inches that is frozen. I've heard reports of Clark County, South Dakota, still some frost at that same level. And one of our stations, Antelope Range in northwestern South Dakota, just in the last couple of days seems to have gone above freezing and thawed there. So we still do, and I missed this one. I apologize. We've got a 20-inch depth to thawing here. So we still do have some deeper frost levels in the ground that we've not removed at this point. Looking at the current snowpack conditions, and then we'll transition on to our partners discussion, where we are in the way of snowpack. You see in most of the basins in Montana and Wyoming running in the category of 140 to 160, 170% of average by this point in the year. Now, this is a combination we should take a point of, in that the percent of average by this point we have usually passed our peak and snow melt has started to occur. So what this is indicating is we are quite high for this time of year, but the total accumulation has not increased much over the last couple of weeks, and the core images will show that as we go along here. All right, now I will hand it over to Kevin Stamm from the U.S. Army Corps of Engineers to talk a little about Corps regulations.
Okay, thank you, Dennis. Can you hear me?
Yes, I can. Go ahead, Kevin.
Okay, great. My name is Kevin Stamm, and I'm a senior hydraulic engineer with the U.S. Army Corps of Engineers in the Missouri River Basin Water Management Office. And I just want to provide a little update on our system status and our forecast runoff as we go further into the spring and the summer. So this is I'll do a quick review of the main stem system. This is a picture of the Missouri River Basin, or an outline of the Missouri River Basin. And the Corps of Engineers in our office manages 6 large reservoirs on the main stem of the Missouri. Dennis, you can hit advance to pull up the photos. There you go. Okay, so these are photos of the 6 reservoirs: Fort Peck Dam and Reservoir, Garrison, Oahe, Big Bend, Fort Randall, and Gavin's Point, from order of most upstream to downstream. The overall storage in the reservoir system is 72.8 million acre feet, so it is a very, very large system. We'll note that about 90% of the storage is contained in the upper 3 reservoirs. So if we were to take all of that storage in the system and put it together into one large pool, it would kind of look like this. We have, I guess this figure here shows the storage levels in relation to the various zones in the reservoirs which we regulate the water out of. Those zones include the permanent pool, which is basically the amount of water that would permanently be stored in the system. Carryover and multiple use zone, which is about 53% of the total storage space in the system. And this zone of the reservoir is essentially our drought storage. So during long droughts, we would draw the reservoir pools down into this zone and release water out of here to serve all of the authorized purposes of the system. Then we have the annual flood control multiple use zone and the exclusive flood control zone, which we reserve for flood control operations. The annual flood control zone, however, as its name implies, does get used usually on an annual basis if we have a full reservoir system. So as we would get into the spring and summer and the reservoir system begins to fill up, the pool levels would creep into this zone, and then throughout the spring, summer, and fall, as we release water from the system, that water is evacuated, and this is done to serve all of the authorized purposes of the system. So as of today, May 1st, 2014, our total system storage is 54.3 million acre feet. This is just below the base of the annual flood control and multiple use zone. So we do have a little additional storage beyond our full flood control storage going into what will be the peak of our runoff season in May, June, and July. So we're very well positioned going into the runoff year. In comparison to where it was on May 1st of 2011, it was at 65.5 million acre feet. So we are, looks like, about 11.2 million acre feet lower than where we were at that time in 2011. And in comparison to 2013, down in the lower left, the storage is higher than where it was at that point. So we are recovering from the effects of the 2012 drought and putting water back in the system so that we have a full carryover multiple use pool. Next slide, please. And as we put together a forecast, one of the factors that we closely monitor, just one of the factors that we very closely monitor, is the mountain snowpack. This is one of several factors that influence how much runoff goes into the main stem system of reservoirs. The other two being rainfall runoff, which can occur from March through October, or really any time during the year if it doesn't occur snow. But really the peak of that rainfall runoff season is March through mid to late summer. Also, we do consider the plain snowpack. Speaking just quickly about the plain snowpack, it was a relatively uneventful year for plain snow, and the amount of runoff that was generated due to plain snow was really not that much above normal in March, and then in April we actually had below normal runoff into the main stem system. So since we are past that, we are looking at continuing to look at our mountain snowpack, and this figure here shows the mountain snowpack as it has accumulated in the Missouri Basin above Fort Peck, which is on the left, and the Missouri Basin between Fort Peck and Garrison reservoirs on the right. And we've depicted that in inches of snow water equivalent. The blue shaded area represents the amount of snow that has accumulated this year, and it is shown in comparison to several different levels of snowpack that we have seen. First off, the bold red line is the 1981 to 2010 average SWE as it has occurred, or as it has been calculated for the reaches. So our current snowpack in comparison to that is showing that we are well above that level. As of today, or I guess as of yesterday, our total snowpack was 21.2 inches of snow water equivalent, which was 129% of the long-term average peak above Fort Peck. Now for Fort Peck to Garrison, the SWE was 19.1 inches, which was 135% of the normal peak, which we're showing there in the red line. A couple other lines that I'm showing there. The light green line shows the mountain snowpack in 1997, and then the darker blue line is the snowpack in 2011. Earlier this month, we were seeing that snowpack tracking fairly closely to the 2011 levels, but it has leveled off. We don't know if it will continue to gain anymore. It's likely we will continue to see some accumulation, but if the snowmelt rates exceed the accumulation rates, then it will begin to fall off, as we typically would experience this time of year. So we don't expect it to reach the 2011 levels unless something phenomenal happens, and they are much lower than what had occurred in 2011. Next slide, please. So finally, taking all this information into consideration, we have come up with a calendar year runoff forecast as of May 1st of 31.7 million acre feet, which is really just a small adjustment compared to last month's runoff forecast. The average annual runoff is 25.2 million acre feet, so we are about 125% of normal runoff for the entire upper Missouri River Basin above Sioux City. Couple things to just note about our adjustments in our forecast. Since we did see slightly below normal in April, we've made some minor adjustments and shifted some of our volume. However, we have in fact increased the amount of runoff that we will be receiving through the remainder of the calendar year. Also pointed out there, our website at the bottom. We have a lot of this information posted to our website, and we will be working on our updated reservoir studies to communicate how we will continue to regulate the system or adjust the system through the remainder of the calendar year. That's all I have.
Thank you, Kevin. Now let's transition to Kevin Lau from the National Weather Service Missouri Basin River Forecast Center.
Thank you, Dennis. Can you hear me okay?
Yes, I can. Go ahead.
Okay, great. Again, my name is Kevin Lau, and I'm with the National Weather Service, as Dennis has said. This first slide that you're seeing shows the areas within the Missouri Basin where the National Weather Service is projecting that flooding is likely this spring. Areas in red indicate that flooding is likely, and areas in yellow denote regions that we are watching, but at this time simulations don't indicate a high probability of flooding in the yellow areas. As has been mentioned already, the above average snowpack, or there is an above average snowpack in the mountains, and the National Weather Service expects that this will result in some flooding in the mountainous west. We are projecting minor flooding in some of the tributaries to the Yellowstone, including Clark's Fork, the Tongue, and the North Fork Shoshone. The North Platte and Laramie rivers are also likely to experience minor flooding as well. That's in Wyoming. Latest model runs do indicate that moderate level flooding is possible in the upper Missouri River Basin above Fort Peck, specifically in the Big Hole and the Gallatin River Basins. However, the National Weather Service at this time still does not expect widespread significant flooding due to mountain snow runoff alone. As we get farther into the spring season with our outlooks, we are seeing an increase in the likelihood of flooding due to convective activity in the lower third of the basin, specifically in southeastern Nebraska, eastern Kansas, and the state of Missouri. And we have already experienced moderate flooding this season in the lower third of the basin, and undoubtedly will continue to do so. Flooding in the lower third due to thunderstorm activity is typical. The Dakotas and the Colorado Front Range continue to be areas that we are watching, even though flooding is not yet indicated by our models. But conditions are such that a wet period could easily lead to flooding in these regions. We did experience fairly widespread and appreciable rainfall in the Dakotas over the past few days, with some rises in the streams, but nothing got close to flood stage. And so we need to take a pretty close look at the soil moisture. Dennis has already alluded to that, but we would have thought that we would have seen more flooding last week going into the event than we actually did. So that's a good and welcome sign. My next slide then is just a few take-home points, and that is that we do have an above-average snowpack in the mountains, and as already been said, the accumulating season, the typical accumulating season, has already ended. The northern plains soils seem to be still wet, at least in the top layer. Some minor to moderate flooding is expected in the mountains, but widespread flooding is not. It would take a rainfall event or a series of rainfall events to set that kind of flooding into motion. We do need to keep watch on the western portions of the Dakotas and in the foothill front range of Colorado, and minor to moderate flooding will continue due to thunderstorms in the lower third of the basin, but this is not atypical. So that's all I had, Dennis, for the Weather Service flood potential brief.
Okay, thank you, Kevin. And I guess to add on to that, to part of that reason why we probably didn't see some of the runoff that we expected gets back to the some of the dry recent conditions we've had. So we have some fairly dry soils in at least parts of the Dakotas. People have been reporting to me about concerns on overall dryness. Okay, let's jump ahead to the outlooks here, and the question everybody has about this is where we are, this is what we think. Now we need to move on to what we think is going to happen. So looking at the Hydrologic Prediction Center, or the Weather Prediction Center from NOAA, potential for precipitation over the next week. The pattern in the northern plains looks to stay active. Models are indicating potentially 1 to 3 inches in areas of Montana, Wyoming, and the western Dakotas. So we could tend to see some more precipitation during this time frame, so it bears watching as we go along here. Going from the 8 to 14 day outlook from the Climate Prediction Center, you see that much of the area stays in the likelihood of being wetter than average, and we're looking now here at the second week of May is where we'd line up. Just a reminder that while the first map shows absolute forecast amounts, this is probabilities of precipitation and not necessarily amounts that we're dealing with here. So we're likely going to stay on the wet side overall. From a temperature standpoint, the overall temperatures are projected to be more likely below average throughout the whole basin. So that would continue to slow the melt-off in the way of snow as we go along, and would also tend to slow any drying because of any additional precipitation from the soil moisture perspective. New outlooks just released for the month of May, fresh off yesterday morning or yesterday afternoon. You see a similar pattern as likely wetter than average continuing throughout the northern plains, throughout the whole Missouri River Basin, with a fairly large 50% more likelihood of above average. That's a fairly significant one for the month, probably largely basing off that the first map I showed you where a couple or 3 inches of precipitation would give us a fairly good likelihood of being above average for the month, even without a whole lot of additional precipitation after that. Below average temperatures are also most likely. As we get into this time of season, those two start to go together more likely that if you are wet, you're going to be on the cool side, and if you're dry, you're on the warm side. So this bears watching as we're going along. Would continue to slow the melt off as we go along. Additional precipitation would not be a great thing on top of the snowpack, as it would lead to quicker flooding and additional chances for flooding. 3-month outlook, May to July. You see the precipitation outlook goes to EC equal chances, indicating they don't think they have enough skill to say one way or the other in the way of precipitation, but that colder than average area is not as strongly indicated, but still sticks over Montana and North Dakota as we go through the May through July perspective. So a little bit cooler than average conditions, probably the way we're going to go as we get in the early part of summer. From a drought outlook perspective, just to complete the picture here, again, no drought areas currently. And with the outlook we're seeing right now, we would probably not see much introduction of drought areas except for our southern parts of the basin, and the outlook is still indicating at least some improvement in those drought areas, as we're more likely to have more precipitation than we lose in the way of crop water use or evaporation. One other note to throw in here is the potential for El Nino continuing. Thrown 2 loops in here, so I apologize for doing double looping on you. Looking at El Nino conditions, here we are in the Central Pacific, watching a loop since February until present. And you can see that while back in February, March, we had colder than average water along the equatorial Pacific, that is rapidly transitioning to warmer than average water. And the reason why, you can see in the lower right-hand image, here we're showing kind of a side view as if you were down towards New Zealand looking up towards the equator, so that this is the west to east across the Pacific, and then depth into the ocean here. Very, very warm water that has progressed its way across from the Central Pacific, that is moving up towards the surface in the Eastern Pacific as part of a Kelvin wave, which is helping to push along this potential for El Nino as we go along. Officially, the outlook probabilities for El Nino, neutral, and La Nina, as we get into April, May, June here, or May, June, July. The May, June, July outlook still leans toward neutral conditions being the most likely, with El Nino not far behind. But as we move into the summertime itself, the probability is over 50% and more likely to be El Nino than neutral conditions. So it looks quite likely, especially as we go along and think about next year, that we will move into an El Nino situation. Probably will not have an impact for us in this runoff season, but we'll have to watch it for next runoff season as we go along. Okay, kind of summarize where we are right now. We have had some recent, we were wet over much of the plains last fall. Some recent dry conditions in parts of the region did reduce some of the runoff from the recent precipitation. I apologize, I probably should have shown you the most recent maps on how much precipitation we had out of the event this week. I'm sorry for doing that. The snowpack overall is still substantial, as we talked about, but is in the last few weeks fallen off the 2011 track, which it was following relatively closely. Still some moist soils in the plains and some frost at depth, especially further north. From an outlook perspective, precipitation does look like a more active precipitation pattern in May, even into maybe the first part of June. This, along with the soil moisture conditions and some of the runoff from the mountains, will increase the likelihood of certain basins having flooding, as Kevin talked with you about. This would be increased further with heavy precipitation amounts. We can't say that too much at this point as to what's going to happen. Overall, the Missouri River is still well within managed issues with the ample flood control space, especially as Kevin Stamm talked about. And El Nino is likely coming, but again, unlikely to impact us this runoff year. Okay, just a reminder of some of the links where you can find some of this information and some of our partners. And that brings us to the end. So we would be happy to answer any questions you have for us. We do have both Kevin's available and myself for any questions you have.
Thank you, Dennis. And this is John again. If you would like to ask a question, you can hit actually #6 to unmute your phone to ask your question. So go ahead.
Yeah, a question from North Dakota.
Yes, go ahead.
Hi, Sean Johnson from Division of Homeland Security. And I hate to ask the dumb question, but I just can't remember. When we look into El Nino conditions into the fall and the winter, what generally does that generate during those seasons, if an El Nino actually occurs, as far as moisture, etc.?
The tendency, and John, I'll let you kibitz on this too if you need to.
Yes.
The tendency would be more likely to be warmer than average next winter throughout the northern plains. From a moisture perspective in the mountains, I think we lean dry during El Nino. Is that correct, John?
Yes, and by the way, if you'd like, after this call, you can go ahead and give me a buzz, and I can actually give you some direct information about that. So,
Okay, that'd be great.
yeah, my phone number here is 816-268-3144.
And that was Kevin?
John Eyes,
John,
E-I-S-E. Yep.
The Climate Prediction Center does have some El Nino composites on it, too, that you can use.
Okay. Excellent. Thank you.
You're welcome. Look forward to your call.
Yeah, this is Doug Peterson with NRCS. Am I on now?
Yeah, go ahead, Doug.
Hey, I was curious as to, we've seen a tremendous amount of land use change down here in Missouri and Kansas and Nebraska where we're at. How big of an area would it take to, of a land use change and all the corresponding increase in runoff and increase in evaporation, how big of an area would it take to impact small small weather patterns in areas. It seems like our most of our here in North Missouri, most of our rainfall is coming across Kansas, and boy, it just doesn't seem like it gets here anymore. And I didn't know if you guys had looked at anything like that.
This is Dennis. We have looked at varying changes in precipitation patterns over time. I haven't looked as much down at Kansas and Missouri because I don't get down there quite as much to talk about that. But, I mean, there have been some land use changes that could, certainly some land use changes up here where we have changed some of that land surface patterns. Down in your area, I guess I can't speak to that off the top of my head. I would have to talk with my cohorts down there.
So is it making a difference? Do you feel it's making a difference in your part of the world then?
Yes. From a perspective of we have changed our agricultural practices and what we're planting over time, which has led to changes in when crop water use is occurring. Whereas we used to be more of a small grains area or grassland, which would use more of their moisture earlier in the season, by late season there would be less ET coming off of those. Because we've transitioned to more corn and soybeans, we're creating more ET, evapotranspiration, at that time of year, so we're seeing increases in dew points and overall humidity later in the season than we used to.
Does the increased runoff from say what would have occurred with rangeland, do you think that is actually, it seems down here that anyway that it's actually reducing our summer rainfall? Now I realize we're in a drought a little bit, but is that, I guess what I'm asking, is that caused potentially by us as well?
Changes in land use could possibly have some part of it. To be able to say explicitly is a bit more complicated.
Sure. Well, I understand. Yeah.
And certainly, you know, there's been more drain tile installed in a lot of places, which gets blamed for some things. But it's a very complex interaction too, as to when soils are drained with drain tile and when they're not. So it's a larger, more complex issue. If you'd like to send me an email, I'd be happy to have a conversation with you and point out some folks you might talk to more down there.
Okay. Thank you.
It's #6 to unmute your line and then *6 to remute. Do we have any more questions for Dennis or our Kevins that are on the line? Okay, well, very good. And you see on your screen there our email addresses and phone numbers. So if you have any questions, feel free to give us a call. And thank you, Dennis and Kevin Lau and Kevin Stam for being here today. Also, Doug, thank you for being with us. And we'll see you possibly at the end of this month. We'll let you know soon about that. Take care, everyone. Bye-bye.
Thank you.